All right, so here we are again, identifying the parts of exponential equations. Last video, we looked at what initial amount is and what a common ratio is for exponential equations. This time, we're actually going to look at the equation, identify the parts from that. I'm going to just go through all these questions here. What is the initial amount? What is the rate ratio? Is that increasing or decreasing? Is that growth or decay? And then I'm just going to give you a quick sketch of that right here on this graph so you guys can kind of see what's going on there. So let's go ahead and go through with this. I got f of x equals 4 to the power of x. Most of my students, when I ask them, this is the first question, what is the initial amount? That's a sub 0, right? A sub 0, and a lot of people say 4, because that's the first number, right? Not quite, because the initial amount is actually in front of the rate, or the base of that exponent, right? So the base here is 4, the exponent is x, but the number sitting right out here in front is what the initial amount is. And in mathematics, if we don't see a number right there, we can assume that it is the number 1. And in my class, we call that the creepy coefficient. So that's really a 1 right here, 1 times 4 to the power of x. So in this case, our initial amount is 1. For the common ratio, that's always the base. So you have the exponent up there, x. Whatever that x is touching is your common ratio. So in this case, the x is up there at the exponent spot. The base is 4, so our common ratio, or r, is equal to 4. And then the question, is that increasing or is it decreasing? Well, to give you the quick rule really quick, the ratio, if the ratio is somewhere between, if it's bigger than 0 but less than 1, basically if a decimal or a fraction that's less than 1, this is going to be decreasing. And I'll show that on the graph in just a second. And then the next thing is what if it's bigger than 1? Okay. If the ratio is bigger than 1, greater than 1, then that means that it will be increasing. Okay? And that'd be a good thing to write down in your notes to keep in mind as we move on through this lesson. In fact, let me move this over just a little bit so I'm going to graph this. I'm just going to do a quick table on this to show the points in which I'm going to be graphing here. If I were to substitute some values in, I'm going to go with let's go with negative 1, 0, 1, and that should be good enough. So if I were to do 4 to the power of negative 1, that would give me 1/4. 4 to the power of 0 gives me 1, and we'll get more into detail how to do this later. And then 4 to the power of 1 is 4. If I were to plot these points really quick, negative 1 comma 1/4 is about right here, 0 comma 1 is right here, and 1 comma 4 is about right here. We could have went out to the next one. If I plugged in 2, it'd be 4 to the power of 2, which is 16. I can't quite fit that on here, but we know that keeps on going up. And so what you end up having is something that looks like this. All right, it's an exponential equation. It approaches the x-axis, doesn't quite touch it, but it does shoot up as we go to the right on the domain. It shoots up really quickly up to infinity. Right? So this is increasing. And it's really easy to tell right away from the ratio because the ratio is bigger than 1. And if the ratio is bigger than 1, that's an increasing function. Okay? And that directly relates to the next question, is that growth or decay? Well, you read a graph from left to right, and if it's going up, you have growth. If it's increasing, it's growing. If it's growing, it's increasing. Okay? They're just synonyms for one another. Okay? Let's try the next one. See if you guys can pull this one off by yourself. Go ahead and pause the video and try this one out. All right, so we have 1/3 to the power of x. Well, what is the initial amount? If you put that the initial amount is 1/3, you got that one wrong. That's okay. You just made a mistake. We're going to learn from it. Remember that in front of the base of the exponent, the base is 1/3, the exponent is x, but what's in front of the 1/3? It's that creepy coefficient, the 1, right? So the initial amount here is 1 again. What is their common ratio? Or the rates, or the ratio here? Well, remember that the ratio is always the base. So we're looking at a function that's in the form of f of x equals a sub 0 times r to the power of x. We found the initial amount out there, and the number touching the exponent is r, right? And what's touching the exponent here is 1/3. So the rate is 1/3. Is that increasing or decreasing? Well, if you wrote down your notes from the last slide, you'd know that any number between 0 and 1, if it's a rate, that means that it is decreasing, which means that it is also decaying. Let's take a look over here on the graph. I'll make a quick table for you on this one as well. If x, we'll just go through a couple numbers. Go negative 2, let's go negative 1, 0, and 1. A couple more points on there to prove my point. F of x is 1/3 to the power of x. And I know these, but you can use your calculator to check these for me. If I plug in x here, and I replace the x with negative 2, 1/3 to the power of negative 2 is actually going to be 9. 1/3 to the power of negative 1 is 3. 1/3 to the power of 0 is 1. And 1/3 to the power of 1 is 1/3. So you just plug these x values into x here, just replace the x. You should be good to go to get those numbers. Let's plot these points. Negative 2, 9 is sitting right here. Negative 1, 3, 0, 1, and then 1, 1/3, I'm just going to kind of guess about right there. You can see that curve happening here, right? But what's happening this time? Is it increasing or is it decreasing as it goes to the right? It's decreasing. It's going down, right? So decreasing and it's decaying. Okay, so make sure you get that down. Again, if you didn't get this on the last slide, that if the ratio is between 0 and 1, or you could basically just say less than 1, it's decreasing. And if the ratio is greater than 1, it's increasing. Okay, so that's what we see here. The ratio is less than 1, so we're going to go with decreasing. Okay, let's try this one out. Go ahead and pause the video. Give it a shot. All right, so f of x equals 1.2 to the power of x. Is there a creepy coefficient there? There is. There is a 1 sitting right here. So what is the initial amount? The initial amount is 1. Because again, we're looking for f of x equals the initial amount times r to the power of x. Right? The exponent is always touching the ratio, not the initial amount. So what is the ratio in this case? The number touching x, which is 1.2. Right? Is that increasing or decreasing? We'll look at the rate. The rate, this is greater than 1, right? If this is greater than 1, what does that mean? That means that this is increasing. Okay? So we got an increasing function here. Is that growth or decay? Well, increasing functions are growing functions. So this is growth. Pretty easy. We have our initial amount, our ratio, increasing, and growth. All just looking at the equation as opposed to having to graph it first or putting it into a table and plugging in points to get the ordered pairs. It's just quick, simple. Try this one. Okay, so same thing here. Is there a creepy coefficient in front of the ratio? In fact, maybe you found the ratio first. You go, well, the ratio is always touching this exponent x, right? So the ratio is 0.10, or maybe 0.10 is what you said. Well, then what's the initial amount? The initial amount's the number in front of the ratio. Well, what's right there? Well, I don't see anything. Well, in math, we don't have to write this number. That's 1. So initial amount is 1. Is that increasing or decreasing? Well, the ratio, is that bigger than 1 or smaller than 1? It's smaller than 1, right? It's between 0 and 1. And so smaller than 1 means that it is decreasing. And decreasing functions are growing or decaying. They're decaying. And let me give you a little hint here. See this right here? Same root right there, right? Decreasing and decay. That might help you. But anyway, there we go. We see a function. Didn't have to graph it. Didn't have to make a table. We can tell you all kinds of things about it already. Okay. Try this one out. Cool. What's the initial amount? This one's actually a little easier to see. The initial amount is not the number touching the exponent, right? The ratio is what's touching the exponent. So the ratio right here is 0.99. So that means that the initial amount is right in front of that. That means the initial amount is 4. Well, is that increasing or decreasing? Don't get confused here. Don't look at the initial amount for increasing or decreasing. You look at the ratio for increasing or decreasing. The ratio, bigger or smaller than 1? It's smaller than 1, so this must be decreasing. So is that going to be growth or decay? That's going to be decay. Woo! Here's another. Go ahead and pause the video. This will be our last one. Give it a shot. All right, so what's the initial amount? What is the common ratio, or the rate, r? Is that going to be increasing, decreasing? Is it growth or decay? Well, remember, the ratio is always touching the exponent, so the ratio is 1.10. The initial amount is sitting in front of that. That's 0.25, or 1/4 if you want to write it as a fraction. So is that increasing or decreasing? Well, the ratio is bigger than 1. And bigger than 1 means that it's going to be increasing. Let's write that down. And then lastly, is that going to be growth or decay? Well, increasing functions mean that they are growing. All right, so this is growth. All right, and that's the last one for this small video-ish, smallish video. So if you have any problems with it, you can email me if you're one of my students. If you get it, move on to the problems just below this on your assignment and try those out, and then move on to the next video. Take notes, do the examples. right? And then do the problems. Just keep on going and going and going until you are good to go and you understand this, right? All right, good luck on that.